So just like we looked at position time graphs and velocity time graphs, we're now going to look at acceleration time graphs. And for an acceleration time graph, the y-axis is your acceleration. The time is written across the x-axis. Our slope isn't as important in an acceleration time graph. Really what we're interested in is the area underneath the curve or the line in an acceleration time graph. That gives us our change in velocity. So what's written in green here is important. It says the area under an acceleration time graph gives the change in velocity of an object. So what is the change in velocity of the cheetah that's motion is shown here between 0 and 5 seconds? Well, between 0 and 5 seconds we have a rectangle, and that is a rectangle with a length of 5 and a width of 4 meters per second squared. So 5 seconds times 4 meters per second squared, that would get us to 20 meters per second. And because the direction is listed as west, the acceleration, the velocity has changed by 20 meters per second in the west direction. So here's an interesting question. It says, what is the cheetah's final velocity? Now, we don't know because we don't know what the initial velocity of the cheetah was. Initial velocity isn't a value that an acceleration time graph can give us. So if the cheetah was starting at velocity of 0, then it would have a final velocity of 20 meters per second. If the initial velocity was 5 meters per second, then it would have a final velocity of 25 meters per second. We can't tell from the graph. So sometimes when you have a question like this, it might say the initial velocity is and give you some sort of value. That is important to make note of because without that value, you cannot find the final velocity. Without knowing the initial velocity, you can't find the final velocity. We only can find the change in velocity. So for an acceleration time graph, the area under graph tells you the change in velocity. The y-axis is your acceleration, and the x-axis is your time. So now let's look at all three of these graphs that we kind of looked at. We have a distance time graph shown on the left. That is it's got a curve, a quadratic type curve. That means that is non-uniform motion. That means that there is a change in the velocity. And if there's a change in the velocity, that means the velocity graph would be linear. And from that velocity graph, we see it's a linear graph. And because it's a linear graph, if we find the slope of that graph, we'll find the acceleration. And we notice that it is a constant acceleration. So that would get us to our acceleration graph, which is a horizontal line. So these three graphs show the same thing. One is showing that the position changes with a curve because there's a constant velocity, so it changes like quadratic. The velocity time graph shows that the velocity is increasing at a steady pace at a constant acceleration. And the acceleration graph shows that the acceleration is indeed constant. It is represented by a horizontal line, which means that the acceleration doesn't change at all. So with those types of graphs of motion, we can come up with this little arrangement here. And what I would like to have you do is copy this down. The slope of a distance time graph can give you the velocity. The slope of the velocity time graph can get you the acceleration. And then going backwards, the area underneath an acceleration time graph can give you the velocity. And the area underneath a velocity time graph can get you the position or the displacement. So this practice question just kind of summarizes everything. This is another good kind of table you might want to copy down. It says, how would you determine the position from a distance time graph? Well, you can just read that from the graph. If you had a velocity time graph, you would have to find the area underneath the graph. But if you had an acceleration time graph, we can't find the position. At least we can't find it directly. Another question, it says, how would you find the velocity from a distance time graph? Well, we can take the slope. How do you find the velocity from a velocity time graph? We can just read the graph. And from an acceleration time graph, we can find the area underneath to find the velocity. And then last question here, how do you determine the acceleration? Well, we can't read that from a distance time graph. We can read the acceleration from a velocity time graph by taking the slope. And from an acceleration time graph, we just look at the time and we can read what the acceleration is. And that is how you would use these different graphs of motion. They are a nice tool for understanding motion, position, velocity, and time. And acceleration. We will be using them. If you have any difficulty, feel free to make a post in our class discussion board and I can help you understand it.